Okay. Thanks, Chair. My name is Xuan Song. I'm from SUSTech. Actually, I'm a fully computer science background. My major focus on such as AI and big data. So today I will share some experience on how to utilize AI and big data to build a smart city. So I think I will share my recent research activities for the further discussion. As we know, with the rapid development of mobile internet technology and big and human mobile urban sensing data are increasing and produced by various kind of sensors, such as smartphone, uh, online social network apps, GPS device. Uh, Obviously, such kind of data can certainly help us to create super smart, perform more effective urban management and create super smart city. There are false demonstration, so such kind of data. Uh, okay. Such as citywide human mobility data from smartphone and citywide human mobility data on transportation network with different transportation mode. And there are also some small-scale human mobility data, such as human mobility data captured by cameras or human mobility data captured by distributed laser scanners. And this is another example, such as GPS trajectory collect of public transportation system of Shenzhen. Shenzhen is one of large city in China. And based on this human mobility, and we can have an overview of the transportation structure of Shenzhen, such as which is the major CBD region, and how about the major road of Shenzhen. My research aims to develop novel algorithm, cutting-edge technology, and applicable system to enable urban intelligence with AI and big data. So by analyzing big human mobility data and utilize some deep learning technology to process such kind of data, and we want to perform such as more effective emergency response and disaster management, traffic accident inference, urban dynamics modeling, and to design next generation intelligent transportation system. And I believe such kind of system will helpful for for some energy application. This is overview of our research. We aim to develop AI and human mobility data-driven platform for more effective urban management. So for the platform, the input should be some mobility data, such as human mobility data from GPS device, from online social network apps, or from smartphone. And based on the processing and deep modeling for such kind of data, and we want to output some urban service or some smart service, such as population density prediction, traffic demand prediction, traffic accident analysis, or epidemic control, such as for COVID-19. And I will show some example for such kind of application, such as firstly, I will show some example for some disaster management or emergency response. And this demonstration shows the human mobility in 2011, while the Greece East sharp earthquake happened, maybe 9 years ago. And we can see that at 8 o'clock, the transportation become very busy. And maybe at 10 o'clock, maybe the transportation is not so busy as before. And this earthquake happened at 2:40 p.m. So we can pay more attention while the earthquake happened, and how about the human mobility pattern, such as, okay, the earthquake will start. Okay, can you see that? Yeah, well, the earthquake happened, and the entire public transportation system of Tokyo is at a standstill. So the fast movement of humans become very slow. And because most people, because entire railway service stopped, so people can only by walk or move by taxi or bus. So the movement of entire Tokyo become very, very slow. So we try to develop some deep learning models, such as for human mobility at some earthquake or disaster case, and we perform some deep modeling and to construct some models. And based on this model, and we can perform the population movement simulation or prediction, such as if some future disaster happen and we want to simulate or predict how about a large number of people will move. And we also perform some evacuation routes recommendation for some disaster case. And then I will show another example for intelligent transportation. I believe transportation is very important for energy community or energy field. So our goal is to predict, such as if we observe some specific person's movement, and we want to predict three things. First one is which places he want to go, and the second one we want to predict how about his travel routes, and the third one we want to predict how about his transportation mode, such as what kind of transportation mode or what kind of transportation demand does he, such as by bus, by train, or by taxi. So we, based on the human mobility data and the transportation mode labeling, and we mapping to urban transportation system, and then we construct a very deep LSTM neural network, and then we can, based on this model, and we can predict the future human movements and their transportation mode. And this is some sample results based on, we can perform some simulation, just a given time and region, and we can generate the transportation sequence transition, such as they walk, train, by car, like this. And this is another example. Because we want to develop some real-time platform. So if we can input some real population movement, and we can predict how about his future destination, and how about population density in next 10 hours, next 30 minutes, next 10 minutes, and in some important station, and we can also predict the density of the population movements. Yeah. And the last example, I will show some example for epidemic control for COVID-19. I believe COVID-19 is currently is a big problem in the world. So we develop AI and human mobility data-driven epidemic simulation platform. So the input should be some human mobility data, and based on our deep modeling of transmission model, and we can output such as predict, find out the primary or secondary context, simulated epidemic spreading, simulated human mobility in response to public policies, or we can also simulate and compare the effectiveness of each policy. And this example, so if we have a confirmed case persons, and we have his such as trajectory at past 2 weeks, and we can input the platform, and we can find some contact persons, such as we can see maybe the red circle shows the infected person, and the yellow one shows the top risk contacts, and the second level risk, and the third level risk. We can trim all these persons separately, such as for the confirmed case or top risk contacts, we may ask them to stay at home. And for other ones, we need to send some message to give them some false alarm, some alarm about you had better be careful, like this. And based on our platform, we also can construct transmission models. And for instance, maybe if there are initially there are 3 patients, and based on their movements, and maybe more and more confirmed case will be generated. And based on our transmission model, and we can perform the simulation, such as the red one shows the infected person, and the blue shows the susceptible person, and the green shows some recovered persons. Yeah, we can run the simulation, and then we can predict the future spreading trend of COVID-19. And this is an example, and we can run the simulation and predict, such as in next several days, how many people will infect if we didn't do if we did nothing. Such as this is in Shenzhen case, because we this maybe is around 10 months ago, and we run the results, yeah, in Shenzhen. And we also can perform some policy simulation, because sometimes a government should publish some policy, such as region lockdown, such as telecommuting, such as detection, and we need to know how about the effectiveness of this policy. So we develop a tool for simulate this, such as if we want to perform the region lockdown. So based on our platform, we can recommend some region to perform lockdown, such as based on POI information. And then we can also perform the detection. But sometimes we need to find which places should locate a detection location station. So based on our platform, based on the human mobility understanding, and we can recommend the detection station should be located where, yeah. And we also can publish the telecommuting policy. So by analyzing the population density, and we can still recommend some good places for telecommuting. And if we set all these parameters in our platform, and we also can choose some parameters for all these settings, and then we can run the simulation. Based on this simulation, we can know how about the efficiency of all these policies, such as maybe we can see the curve. For instance, if we perform telecommuting lockdown or detection, and the curve should be like this. So it shows that such kind of policy should be very effective for prevent COVID-19 spreading. Yeah. Okay, that's all. That's my input for this discussion.
Yes, thank you very much. It was very interesting, and it was very impressive to see all the animations as well.
Okay, thank you very much.
Thank you.